Today we're going to talk about simplifying algebraic expressions. First, we need to define what a term is. A term is a number, or a variable, or a product of numbers and variables raised to powers. So let's see some examples. You know what I mean by that. 4 is a term because it's a number. Z is a term because it's a variable. 5x is also a term because it's a product of 5 and the variable x. 2/5 z is a term because it's a product of 2/5 and the variable z. Negative 4xy is the product of negative 4, x and y, so that's a term. Negative x squared is the product of negative 1 times x squared, x raised to a power. And 6x cubed y to the 4th is also a term because it's a product of 6x cubed and y to the 4th. So all of these are terms. Now when we talk about terms, we often talk about their coefficients. And the coefficient is the number that appears in the term. So for the term 4 is the coefficient. So 4 is its own coefficient. You can think of it that way. For z, when you just have a variable, there's an understood coefficient of 1. 1 times z, or 1, for the coefficient. For 5x, the number is 5, so that's the coefficient. For 2/5 z, the coefficient is the fraction 2/5. For negative 4xy, the coefficient is negative 4. See the number in front of all the variables. For negative x squared, that coefficient, that negative sign is really a negative 1, so that's the coefficient of that term. And for 6x cubed y to the 4th, 6 is our coefficient. Okay, we're going to have a couple of examples here, and our job is to see if each of these expressions are terms. And if it's a term, we're going to talk about its coefficient. So the first number we have here is negative 13. Yes, that's a term because it's a number. And negative 13 is its own coefficient. For our second example, we have 7 times x, 7x, which is a term. It's the product of 7 and variable x, and the number 7 is the coefficient. In this example, we have 34 minus 5z. That is not a term. Actually, really, it's two terms, but we'll talk about that later. And finally, here we have negative a squared b squared. And again, this is a product of variables raised to powers with the negative 1. So yes, this is definitely a term. And the coefficient is negative 1. Now, with algebraic terms, we can form expressions. And expressions are terms that are added and subtracted to each other. So we're going to simplify these expressions. And in the first problem we have here, we have this parentheses. And that negative 2, that means multiplication. Anytime you have a negative 2 or a number up against the parentheses like that, that means multiply. So we're going to use distributive property. And negative 2 times 3z is negative 6z. And negative 2 times negative y, 6y, is 12y. And then you bring down the negative 2z. Now we're going to add the like terms. And we have a negative 6z and a negative 2z. And you're going to add those two. If you remember, when you add two negatives, you keep the sign and you add the numbers. So that becomes a negative 8z plus 12y. And that's as far as we can go because those are not like terms. So we're done simplifying. Let's look at the next example. Okay, this time we have a negative sign in front of this parentheses. We're going to distribute that, and that negative sign is like having a negative 1. So you're going to multiply a negative 1 throughout that parentheses. So the negative 5 comes down. Negative 1 times positive 5x is negative 5x. And -1 times -6 is +6. Notice how the signs inside the parentheses all changed. Now we're going to look at the like terms. And these are the numbers -5 and +6. And remember, we're going to keep the sign of the larger one of those two, which is the positive, and we're going to subtract. And then that gives us 1 minus 5x for that problem. In this problem, we have an algebraic expression with 4 terms. 2 of them have z-squares, and they're like terms. And 2 of them have z's, and they're like terms. So we're going to combine the like terms. Remember that coefficient of -z² is like a -1, so we're going to write 2 minus 1, which is 1z², or just z². And -1z plus 3z is a positive 2z. And these are not like terms because of the exponents, so we're done with that one. Okay, now we have a word problem. We've got 2 snowblowers that can clear a driveway. The first blower removes 20 cubic feet per minute, and the second blower removes 30 cubic feet per minute. And the first part of this problem is to write an expression that gives the number of cubic feet of snow that can be removed by both blowers working together in X minutes. So in X minutes, the first blower, well, in 1 minute, the first blower can remove 20 cubic feet. So to find out how many cubic feet the first blower can remove, in X minutes, we would multiply 20 times X. And that would give us the cubic feet of snow that the first blower can remove. The second blower removes 30 cubic feet per minute. So in 1 minute it removes 30 cubic feet multiplied times X minutes, and that gives us 30x cubic feet of snow removed in X minutes by the second blower. And together, the 2 blowers, we will add these like terms. They can remove 50x, 50 times x, cubic feet of snow. So that's part A. In part B, we want to find the total number of cubic feet of snow removed in 48 minutes. So that tells you that x is 48. And we're going to substitute our 48 into our expression from part A. Substitute that in for x, and that's going to give us how many cubic feet of snow the 2 blowers can remove in 48 minutes. And so 50 times 48, well, that's equal to 2,400. So 2,400 cubic feet of snow get removed in 48 minutes by the 2 blowers. Now let's look at part C. How many minutes would it take to remove the snow from a driveway that measures 30 feet by 20 feet if the snow is 2 feet deep? So I'm drawing a driveway here. Kind of looks like a rectangle. And it's got length 20 feet and width length 30 feet and width 20 feet. And the height of the snow is 2 feet. And so we need to figure out the volume of this. It would be like a very flat box if you think of it that way. And so the volume would be found by multiplying the length, the width, and the height of the snow together. So 30 times 20 times 2. And that's going to give us 1,200 cubic feet of snow that the driveway has. And we have to remove that with our 2 blowers. And remember our blowers from part A? They remove 50 times x cubic feet in x minutes. And so we know that that has to equal 1,200 because that's how much snow is on the driveway. So we're going to solve for x. 50 times what number is 1,200? And if we divide both sides by 50, 1,200 by 50, then you will get that it takes 24 minutes to get rid of all that snow.